fun begins. We have a linked list for students, so you don't have to touch this main file. And inside, we have some functions to have. So this linked list has two constructors. Here's one constructor, here's the other constructor, okay? If you don't, okay, well, we'll talk about the constructors in a second. It has something called AddToHead, which adds to the front of the linked list. It has something called AddToTail, which adds to the end of the linked list, okay? It has something called delete, all right, and then it has something called toString, which overrides string in object, right? And remember, object, everything inherits from object, and object's the universal base class, okay? So it's a technical override. And it needs to return a string representation of the linked list, and it tells you what that's expecting to do here. And it hopefully prints it out here on the console, okay? There's draw list, which you don't have to touch. We'll talk about it later, but actually it might be useful for you because it tells you how to traverse a linked list, or it gives you an example of traversing a linked list. And then we have our inner class node, and the reason we make it an inner class is because linked list depends on node, and we really are not going to use node outside of this linked list. So if we're not going to use node, if no one needs to ever access node and use it on their own, we're only going to use it with linked list, we can make node just an inner class of linked list. And the way we do that is we have the class linked list, and here's the end of linked list, and then we have class node, okay? And interesting enough, node has some private variables, but since it's an inner class, the outer class can access and manipulate those private variables. So we don't need getters and setters, okay? And we don't even need a constructor, because if you say new node, open parentheses, close parentheses, and don't have a constructor defined, this will still work. It'll use the default constructor that Java gives you, and all that'll do was it'll give you space for your variable data and space for your variable O. And I changed it from link to next just because I don't want you to get confused with all the links running around, okay? So it's next. All right, so those are the private variables. I felt like I was going to sneeze. Sorry about that. I still feel like I'm going to sneeze. So data and next, okay? And remember, next is a node, and data right now is an int, okay? And this is how we create a node. This is how we construct a node, okay? And then we can use we can get data of a node directly from the class. So well, we'll get to it. Let's get to it right now, in fact, okay? So I don't want to completely ruin the plot for you. All right, so we're going to come up here, and the first thing I want you to do is I want you to implement these constructors, okay? And so one of the constructor makes the linked list an empty list, okay? And what we say with that is if the linked list is an empty list, well, that means that the head is referencing null, okay? The head is head node is referencing null, okay? Notice that there's only one private variable in linked list. It's the head, okay? And you can think to yourself, wait, but the head is the whole list, right? Because if the head references a node, and that node references another node, and that node references another node, and that node references another node, my head might just look like it's referencing one node, but really we can go deeper and deeper and see more and more nodes, okay? And so, pretty cool. My head is here, okay? And we need to make the linked list an empty list, so head has to reference null, okay? So how do you set head equal to null? Well, I think you know how to do that. And so you can pause the video and replace or put your empty list here. So if nothing is passed in, if we just create a linked list by saying new linked list, we're going to make this head equal null. Okay? All right. But what if someone wants to start the linked list with a given value? Okay, a given initial data. So if someone says, you know, if I have linked list my list, okay, and I say my list equals new linked list, open parentheses, close parentheses. Let me make this bigger. Sorry. And you can't even see that. Okay, so linked list my list, and then my list equals new list, and I don't pass anything into here. What should happen is head should reference null. Okay. Otherwise, if I say linked list my list, okay, and I say my list equals new, so I'm invoking the linked list constructor, linked list, and I say 5, okay, what's going to happen is 5 is going to be passed in for initial data, okay, and where's initial data? It's right here. So if initial data, if 5 gets passed in for initial data, what we need to do is we need to, 1, create a new node. So we create a new node, right? And we can do that by invoking the default constructor, okay? So that creates a node, and that gives us a slot for data, and that gives us a slot for next, right? Which is our link in this case, okay? Our link to our next node, right? And then we have to set the data to whatever is passed in, okay? And the way we can do that is we could say something like head.data, because we're allowed to use the private variable directly because it's a inner class of linked list. So head.data is totally allowable, okay? And we can do whatever we want with that, okay? So we can set it equal to stuff or whatever. And so you want to figure that out, right? And then we also want to do, if you want it to be specific, head.next, well, if we start with one value, this node should be the first node, right? Head should reference a node with the value 5 in it, and the node with the value 5 in it, well, that should reference null, right? So it says something about the next to make this not just the first element of our linked list, but the last element of our linked list, right? Because the last element, the last node in our linked list will reference null, and head points to the first, or references the first node in our linked list. So what that implies is that you need to create a node. You can invoke the default constructor. Set the data of that node. You can set it directly using head.data, okay? And set the link, which we're calling next, right? Such that this node, next of that node, such that this node is also the end of the list, because you're starting it off, you're giving it initial data, so that creates one node. It's the beginning of the list and the end of the list in this case. So there's two different ways we can create a linked list, okay? And you can test that by, you could actually put a breakpoint in here. And why don't I do that? Why don't I actually, you can't test it. We have to implement this before you can test it, okay? And what am I in on this video? Well, I guess it doesn't matter. Why don't we, so pause the video, try to implement the constructors, and then why don't we implement add to head, and then I'll show you a way you can test it. Oh yeah, it'll test automatically anyways. But it should once we implement add to head, it should show up on the screen. Okay, good. I thought of this. I just didn't remember I thought of this. Okay, so pause it. Try to figure out how to do these two constructors. You won't know, but I think it's pretty straightforward. And then what we're going to do is we're going to do add to head, okay? And you can unpause whenever you're done with the first two constructors. And now we got to think about how to add to head, okay? So in every situation, whenever we do anything with a linked list, we're going to make sure it works for a few different cases, okay? We're going to make sure it works in the empty list case. And we know that's head referencing null, right? Null's a keyword in Java, right? You know this. Okay. You can also think about, well, what if your list has one element? Okay, and that means head, and then you can just make up an element. 5 equals null, okay? And then you can think of the two element case too sometimes, because it's sometimes interesting. Rarely, but sometimes could be interesting. Okay, so head is 5, 6, null. Okay, and then finally the n element case. And what I mean by that is head is referencing a value, which is referencing another value, which is referencing some other values, which is referencing some other value, which is referencing null. Okay, so you don't know how many things are in between there, but this should still work for all of those. Okay, and the question is, in this case, right, so no matter what, you should be thinking of all 4 of these cases and making sure your code works for all 4 of these cases. So it's always the same thing. You write down all 4 of these cases and you say, okay, I'm thinking of this code. Does it work for the first case? Does it work for the second case? Does it work for the third case? And does it work for the fourth case? Okay. All right. So if we want to add something to the front of the list, okay, and let's look at the first case where head is null. Okay, so if head equals null, right? And we wanna, and someone says, I wanna add the number 10 to this. Okay, well the first thing we do is we create a node, okay, and then we set the node's data to 10. Okay, so far so good. And then, well, and then we can also set the nodes next to null, right? Because it's going to be the first node and the last node, okay? And so then we can say, well, head, and then we can set head equal to that node. Okay? And in that case, we'll have head, all right, referencing a node with data 10, and that referencing null, okay? All right, so set the head equal to that node, and that would be the end of adding to the front of the list, or to the head of the list, in the null case, okay? So the null case is pretty simple. You make a new node, you say head equals that node, and that node's next is going to point to null. And that makes sense, right? Because it's not just the first one in the linked list, it's the last one in the linked list. A lot like we just did with the constructor, right? Because the constructor is like head is pointing to null initially, and then we have to make it point to something. So it's basically that, okay? You could actually, well, don't worry about it. We're not gonna, I don't want to talk about that. Okay. So now, what if it's one element? Well, you'll actually find that, okay, if it's one element is already in there, right? So it's like someone, I'm sorry, 5, and then someone wants to add 10 to the front, right? So add at the head, okay? Well, what do we have to do? Well, the first thing we have to do is we have to create a node with the data 10, okay? And its link, or its next, should be what? Well, what we eventually want is we want head to reference this node of 10, which references this node of 5, which references null, okay? Or to put this another way, 10, so we create a node, and 10's next, okay, is going to be this node, right? So 10's next node is going to be the same node, so set next to the same node head is referencing. Okay, and you'll have a situation like this. Okay, if you do it correctly, you'll have a situation where head is equal to 5. It's referencing 5. I'm sorry, don't say equal and null. Okay, and then we'll have a node 10. Okay, and its next will equal 5. And what do we call this? Well, two things referencing the same element is a shallow copy. So you want to make sure the next of this node is a shallow copy of head. One line of code, really easy. Okay. But this obviously isn't right? Because we need to have a train car thing. So the final thing you have to do is you have to make sure head references that new node you created. Okay? So, and once you do that, you've got the train car. So to add 10 to the front in the one case is we create a node with data 10, we set next to the same node head is referencing, okay, and then we want to make head reference the new node. All right, and if you do that, we're in business, okay? So, pretty straightforward, all right? Anything else? All right, so once you implement that, you should be able to see the actual, you should be able to actually add stuff to your linked list, okay? And that'll give you an idea that stuff is working. Okay, so let's do that real quickly. This is an implemented version, so it's not the version you're looking at, obviously. And I'm going to hit 1 to insert data. Okay, and I'm gonna hit 12, and 12 shows up there. And the reason 12 shows up there is because, oh wow, it disappears when you go to another screen. That's funny. So the reason 12 shows up there is because in here we are actually invoking add to head, okay? And so since we're invoking add to head, it'll come in here and you'll add it to head. Okay, you'll make the node and you'll add it to head. All right, and then what it does down here is what we'll learn is it'll go through and try to print it out. So if you have it correctly, that should work. Notice that I didn't talk about the end case. So let's talk about the end case real quickly. The reason I didn't talk about the end case is because it actually ends up being the same. So if I have head, right, and it's pointing to a thing, and it's pointing to another thing, and that's pointing to null, and I want to add a node with the number 10 on it, I'm just doing the same exact steps. I'm making sure the next is head, and then head is the new node, and all of these take care of themselves because they're already pointing to each other. So this is also the general case, okay? But it's good to do this kind of math in your head, well, to make sure that that is the case, and it is here, so we're good. So you got to make sure the only special case is head is an empty list, which is often a special case. Okay, so yeah, you should see stuff show up. Let's if you did this right. And so I'm going to come in and I'm going to enter 1, and then I'm going to enter 22, and then I'm going to enter 1, and I'm going to enter 77. Triple digit numbers, like you could put triple digit numbers in, but the spacing here is such that it works best with double digit numbers. Triple digit numbers will start to look weird and probably eventually overlap with each other. So I would just keep it as long as you're testing to double digit numbers so you don't get confused here. Oh, 1 to insert data. Please enter the number to insert. And so 10 got added to the front, 77 got added, so 22 first got added to the front, then 77 got added to the front, and then 10 got added to the front. Notice it's adding it to the head, right? And so it's adding it to the front of the list, okay? Cool. All right, so hopefully that works out. If it doesn't, you can debug this, and it actually looks kind of cool in the debugger. Let's let me show you an example of that. I'm gonna set a breakpoint somewhere. Where should I set the breakpoint? I'm gonna set a breakpoint at the end of add to head, for example. Okay, and I'm going to debug, and I know you can't see me set the breakpoint, but assume I set the breakpoint at the last curly brace of add to head, and I'm saying 1 to insert, and the number I want to insert is 22, okay, and it hit the breakpoint, so it hit the last curly brace of add to head. And what do we have here? Well, oh God. What do we have here? We have my variable window. In my variable window, data to add is 22. That's what we passed in, right, when we hit 22 on the thing. Okay. To add is an instance of node, right? So, and what it is set to? Well, its data is 22, and its next is null. All right. So this was the first one, and that's what it got set to. All right. And head is also is pointing to the same thing as to add, right? And so so far so good. Okay. So head, we created a node, and head is referencing that node we created. Okay. And when we end this function, head will be pointing to that node. Okay. Let's do something. So let's see if I hit continue, right? It erases when I take this to the other window. I shouldn't have taken it to the other window. Okay. And then I'm going to hit continue again. Did I hit another breakpoint? All right. 22 showed up there. I'm gonna hit continue again. How many breakpoints do I have in here? Can I undo that breakpoint? No. Oh, great. Okay, I'm just gonna keep on hitting continue until we get my dialog box back. Okay, so we got my dialog box back, and it says enter 1 to insert and 0 to delete, and I'm gonna enter 1 to insert. Okay. And it says please enter the number to insert, and I'm gonna go 33, and I'm gonna hit OK, and then I should have hit another breakpoint. Where's my other breakpoint? Where am I? Where am I? Continue. Okay. All right. So now what's happening is did it go into this? Oh, it did, but it went to draw list. Well, so now the next of head is not pointing to null. So head is now pointing to 33 because we insert 33 at the head, right? And the next of head is not pointing to null anymore. It's pointing to another node, right? That's got the data of 22 in it. So head is referencing data with 33 in it now, right? So we created that node and we made sure head referenced it, but before we did that, we made sure the next of this node referenced this node, okay? So now, if you look at it in debug world, it looks less like a list and more like a Russian doll, right? Where the inside of the next is another node, and the inside of the next of that is another node, right? But it's easier to imagine it like this, okay? Both are valid. So you can kind of make sure what's going on is correct, okay? And if it's correct, you'll see it rendered onto the screen. Exciting. So once you do that, you've done the first function of a linked list. Pat yourself on the back if you've gotten it to work. And be excited. I will see you next video. All right. And if you don't get it to work, make sure you use the debug and see what's wrong. That's probably the easiest thing to do. And think about the cases. So empty list case and the rest of the cases, right? There's only 2 things you have to worry about in add to head. I'll see you in the next one where we will talk about how do you delete this thing, right? So you can add to head. Can you delete? That would be really cool. Next video, we're linked listing. What if I hadn't recorded this? That would make me